Our group members: Siti Nurbalqis binti Muhammad Rashid, Muhammad Nazim bin Muhammad Saleh, Siti Muslihah binti Zaharuddin, Amir Hafizi bin Abdul Hardi, and Nurul Hanani binti Zainal Abidin.
In this study, a person needs to roll 2 dice at one time for 20 times, and we need to observe and record them for 4 types of objectives that we have. After that, the calculation for the probability getting an even number for both dice, odd number for both dice, getting a same number for those 2 dice, and getting one even number and one odd number for 2 dice will be taken. By using those results, we will show you a live result for a dice experimental probability calculation, and also show you how to calculate this experiment based on the theoretical probability that we learned in the class. From the introduction that I have been presented just now, this is our objective for this study. First, to calculate the experimental probability of rolling the same number for both dice. Second, to calculate the theoretical probability of rolling the same number for both dice. Third, to calculate the experimental probability of getting even number for both dice. Fourth, to calculate the theoretical probability of getting even number for both dice. Fifth, to calculate the experimental probability of getting odd number for both dice. Sixth, to calculate the theoretical probability of getting odd number for both dice. Seventh, to calculate the experimental probability of getting one even number and one odd number. Eighth, to calculate the theoretical probability of getting one even number and one odd number. And the last one is to compare between the experimental probability and theoretical probability of each event that has been stated to you just now.
Our group experiment for STA 150 is about rolling 2 dice at the same time. Firstly, we need to have 2 dice which contain 6 side dice that contain number 1 until number 6 only. Secondly, roll those dice at the same time until the number are showing on top of it. After that, record the result before then completing the table to make it easier. For each objective that has been explained just now, we need to repeat to roll the dice 20 times each. Then, the result will be taken by using the tally chart to make it easier to complete the table. From the tally chart result that have been shown to you for an event of getting the same number for both dice for 20 trial of rolling the dice just now, we can see that there is 4 out of 20 trial of the experiment is based on our objective to get same number for both dice. So the probability of getting same number for both dice is 4 over 20 and can be simplified to be 1 over 5 for the experimental probability. Now, I will show you how to calculate the probability of getting same number for both dice based on the theory. As we know, each of the surface doesn't now have any same number for one dice and there is 6 surface for each dice. So, we can conclude that probability of getting one of the number from the dice for one dice is 1 over 6. But how to calculate the probability of getting the same number for 2 dice? We can conclude that the probability of this event based on the formula probability A intercept B equal to probability A times probability B. So 1 over 6 multiplied by 1 over 6 equal to 1 over 36. The comparison between experimental probability and theoretical probability experimental probability subtract theoretical probability, or theoretical probability subtract experimental probability. Experimental probability subtract theoretical probability. 4 over 20 minus 1 over 36 equal to 31 over 180. Secondly, theoretical probability subtract experimental probability. 1 over 36 minus 4 over 20 equal to negative 31 over 180.
For an experiment probability calculation, we'll be using the tally chart result that we get from the video that we already showed you just now. From the tally chart result of getting even number for both dice for 20 trial of rolling the dice just now, we can see that there is 7 out of 20 trial of the experiment is based on our objective to get even number for both dice. So the probability of getting even number for both dice is 7 over 20 for the experimental probability. Now I will show you how to calculate the probability of getting even number for both dice based on the theory. As we know, the 3 out of 6 of its surface is an even number. So we can conclude that probability of getting an even number for one dice is 3 over 6. But how we want to calculate the probability of getting even number for 2 dice? We can conclude that probability of is even based on the formula probability A intercept B equal to probability A times probability B. So 3 over 6 multiplied by 3 over 6 equal to 1 over 4. The comparison between experimental probability and theoretical probability. Experimental probability subtract theoretical probability, or theoretical probability subtract experimental probability. Firstly, experimental probability subtract theoretical probability. 7 over 20 minus 1 over 4 equal to 1 over 10. Secondly, theoretical probability subtracts experimental probability. 1 over 4 minus 7 over 20 equals to minus 1 over 10.
For an experiment probability calculation, we will be using the tally chart result that we get from the video we already showed you just now. From the tally chart result of getting odd number for both dice for 20 trial of rolling the dice just now, we can see that there is 8 out of 20 trial of the experiment is based on our objective to get odd number for both dice. So the probability of getting odd number for both dice is 8 over 20 and can be simplified as 2 over 5. That's for the experimental probability. Now, I will show you how to calculate the probability of getting odd number for both dice based on the theory. As we know, there are 3 out of 6 of each surface is an odd number, which are 1, 3, and 5. So we can conclude that probability of getting an even number for one dice is 3 over 6. But how about the probability of getting odd number for 2 dice? We can conclude that probability of this event based on the formula probability of A intercept B equals to probability A multiplied with probability B. So 3 over 6 multiplied by 3 over 6 equal to 1 over 4. Now, we will see the comparison between experimental probability and theoretical probability. To compare between these two probabilities, we need to subtract between those probability, which means 2 over 5 minus 1 over 4 equal to 3 over 20, or 1 over 5 minus 2 over 5 equal to negative 3 over 20.
From the daily chart result that have been shown to you for an event of the getting one odd number and one even number for the two dice for 20 trial of rolling the dice just now, we can see that day is 6 out of 20 trial of the experiment is based on our objective to get one odd number and one even number for two dice. So, the probability of getting one odd number and one even number for three dice is 6 over 20. And can be simplified to be 3 over 10 for the experimental probability. Now, I will show you how to calculate the probability of getting one odd number and one even number for two dice based on the theory. As we know, one dice have 6 surfaces and 3 of them is odd number and the other 3 is the even number. So, we can compute the probability of getting odd number from the dice for one dice is 3 over 6. And the probability of getting even number from one dice is also 3 over 6. But how to calculate the probability of getting the one odd number and one even number for two dice? We can compute that the probability is of this event based on the formula. Probability bracket A intersect B plus probability A prime intersect B prime equal to probability A multiplied P probability B plus probability A prime multiplied probability B prime. From this formula, we can assume that A is even number and B is an odd number for this experiment. So A prime is an odd number and B prime is an even number. So 3 over 6 multiplied by 3 over 6 plus 3 over 6 multiplied by 3 over 6 equal to 1 over 4 plus 1 over 4 equal to 1 over 2.
Now, we will see the comparison between experimental probability and theoretical probability. To compare between these two probabilities, we need to subtract between those probabilities, which means 3 over 10 minus 1 over 2 equal to negative 1 over 5, or 1 over 2 minus 3 over 10 equal to 1 over 5.
In conclusion, the probability of receiving the number of a random variable x were different for each trial by doing all 4 probability experiments. We can also know the difference between the experimental probability and the theoretical probability of a random variable. And this is reasonable to state that probability plays an important role in the solution of the statistical problems.